Welcome friends. Last video I replaced all the timing components and installed the timing cover. In part 4 I'll be reassembling the rest of the engine and starting her up. I needed to install the new valve covers, starting with the driver's side by putting an 8mm bead of RTV on both sides of the mating surface, where the timing cover meets the head. From that point I had 4 minutes to get the valve cover on and tighten the bolts based on the Ford service manual's torquing order with a 10mm socket at 89 inch-pounds. I also verified that the cam oil solenoid seals were seated down over their shoulders. On the driver's side, I did the same thing, applying the RTV and torquing down the bolts. I had a bit of corrosion in the spark plug wells, so I lightly scrubbed them with a brass brush and vacuumed them out using a hose adapter. Now I could reinstall the 2 sensors that I pulled off of the old driver's side valve cover using an 8mm socket, and the ignition coils back in the proper locations with a bit of dielectric grease around the inside, also using an 8mm socket and torquing them to 62 inch-pounds, and then an additional 50 degrees. Next, I started sorting out all of the wires and plugging them back in. I started with the ignition coils and the 2 sensors at the back of the driver valve cover, then the cam oil solenoids, and then the oil pressure sensor plug, which is on the side of the engine next to the steering column. And then finally, the oil pump control solenoid on the front. There should be 4 connectors left on the passenger side, which go to the high pressure fuel pump, auxiliary water pump, throttle body, and the intake map sensor. I think I should have done the high pressure fuel pump first, but I tried to follow the instructions, which I didn't always do, but I did the intake manifold next, installing the 6 new seals on the underside, making sure to pull out the yellow cloths that I had on the intake runners in the heads, and then placing the manifold in position to use an 8mm socket and torque the bolts in the proper order, first to 89 inch-pounds and then an additional 45 degrees. Then I could clip the driver's side hoses back on, reconnect the sensor on the back of the manifold, put the wire harness retainers into position, and reconnect the throttle body. I needed to salvage a couple parts off the old passenger side valve cover, including the high pressure fuel pump mounting plate and the PCV nipple. I removed them using a T45 Torx bit and an adjustable wrench. The plate itself has 2 small O-rings which seal the bolt holes through the valve cover to the passenger head. On the head itself, I pulled out the roller tappet to identify bottom dead center. It was difficult to see, so I just reinstalled the roller tappet and then rotated the crankshaft until I could notice that the tappet was at its lowest point. Then I pulled it back out, lubed everything up, including the diamond-shaped seal, replaced the O-ring on the high-pressure fuel pump itself, and installed the plate and pump into the head at the same time, tightening the bolts evenly. This is done in 5 stages using the T45 Torx bit. Stage 1 is finger tight. Stage 2 through 4 are just tightening each bolt 360 degrees back and forth. So you do bolt 1 360, and then you go to bolt 2 360 degrees, and then back to bolt 1, just like that, back and forth, until they both reach 89 inch-pounds. Then finally tighten them both an additional 45 degrees. Then I could tighten the mounting bolt to 89 inch-pounds. After pressing the fuel hose retainer back onto the valve cover, it was time to install the fuel hardline itself, running from the pump to the fuel rail on the back of the engine. I bought a new one of these, but after reading that it could be reused, I just gave it a shot and returned the new one. The caveat to this is in the actual torquing procedure. So first I tightened the flare nuts finger tight, and then the 2 retaining bolts finger tight. Then I used a 17mm crowfoot to torque the flare nuts in 3 stages. Stage 1 is 62 inch-pounds, stage 2 is 89 inch-pounds, and for stage 3 I needed to use a torque wrench set to 55 foot-pounds, because in stage 3 I tightened the flare nuts an additional 30 degrees. Ensuring that the torque never actually reached that 55 foot-pounds. That's the caveat to whether or not you can reuse these. If it goes over 55 foot-pounds, you have to replace the pipe. This was easy using the crowfoot on the top of the valve cover, but seemed impossible on the nut on the back. I had to get an extension, and the adapter sizes had to be just right. I was getting rid of the IAG air oil separator, so I reinstalled the stock PCV nipple into the passenger side valve cover and connected the hose to the intake manifold. I also installed the stock oil filler neck, and I should have installed the oil dipstick, but I completely forgot about that until later. Next for me was installing the alternator. First, installing the stud bolt using a 7mm socket to 71 inch-pounds. Then I slid the alternator onto the stud and tried rotating it into place, but it just wouldn't go. So I carefully tapped the metal with a mallet until the lower bolt hole lined up. Now I could tighten down the nut and bolt with a 15mm deep socket, torquing both of them to 35 foot-pounds. I didn't show it here because of the new wiring that I installed, but this is also where I installed the wire and nut at 150 inch-pounds and clipped the alternator connector in. Next, I installed the harmonic balancer using an installation tool. Since you can't see the end of the harmonic balancer throat, it's difficult to tell if it's actually all the way on. I ended up over-torquing the installation tool and stripping out a few threads. Luckily, the bolt size is M12, and I had the correct tap size to fix the mistake. I threw on the new bolt and washer, using the old belt and a pair of vice grips as a strap wrench, and torqued the bolt using an 18mm socket in 3 stages. Stage 1 is 37 foot-pounds, stage 2 is 90 degrees, and then stage 3 is 60 degrees. The manual says that it takes 2 people to accomplish this, and I agree. Also, my makeshift belt wrench sucked, and it didn't really work. Next up was the new water pump. I lubed up the seals using fresh coolant, and then used the manual's torquing order using an 8mm socket to torque the bolts to 89 inch-pounds, and then an additional 45 degrees. Except this guy. I somehow completely missed him until pressure testing the system later. So I happily moved on to the outlet connector, which I did not get a replacement seal for. And I didn't want to have to wait, so I cleaned up the seal and I flipped it around so that it was, I had the clean mating surface directly onto the water pump. I torqued those bolts to 89 inch-pounds and then an additional 45 degrees. I slid the new thermostat housing onto the connector hose, and I did a really bad job installing the thermostat housing. This is awkward because the throttle body is in the way, and there are 2 pipes running into the engine. One is a male fitting, and the O-ring is a really tight fit. I reused the old bolts, and I pulled them one at a time from the old thermostat to tell where they went. The order of torquing is critical here to make sure that you don't tear the O-ring on the engine. It's basically the topmost bolt, and then the bottommost bolt, and then the middle bolt, driver side, and then passenger side. Torquing to 89 inch-pounds, and then an additional 45 degrees. Then I put the hose clamp on and installed the water pump pulley bolts using a 10mm socket, torquing them to 18 foot-pounds. Then I could install the belt tensioner with a 10mm socket, again to 18 foot-pounds. I paused here because I realized that I needed to swap out the oil filter, so I went ahead and removed that, allowing it to drain, and then I installed the idler pulley using a 15mm socket to 18 foot-pounds. Next was the AC compressor belt using a zip tie and 18mm socket. The belt is slid behind the harmonic balancer and then installed flat onto the AC compressor pulley. The zip tie is placed just to the right of a spoke on the balancer and around the top of the balancer, and it will hold the belt flat on the top. When I rotated the crankshaft 180 degrees, the belt gets held in place and then pulled onto the balancer. My wife had my wire cutters, so you'll see me using these tin snips way too often. With the oil fully drained, I cleaned up the surface, lubed the filter seal with some oil, tightened it hand tight, and then turned it an additional 360 degrees. Now I could install the new serpentine belt and move on to the myriad of coolant hoses, starting with reinstalling the auxiliary water pump onto the timing cover using a 10mm socket. Then I connected the hose to the thermostat housing. I also reconnected the hose going to the auxiliary transmission oil cooler. The passenger side water pump hose was one with those awful clips. Mine was still sitting on the old water pump, so I pulled that off and then reinstalled it into the hose before reconnecting the hose to the pump. Here I barely remembered to reconnect the auxiliary water pump wire. Then I grabbed a coolant control valve hose, which I had tucked up into the battery tray, and I connected it to the water pump outlet. Then I installed my new Mishimoto upper radiator hose to the thermostat housing. I reconnected the hose on the bottom of the upper radiator hose, and also the lower radiator hose to the thermostat housing. The oil cooler, and then finally the radiator itself. This was extremely hard. I lubed up the lower radiator hose's interior O-ring with coolant, but it's an insanely tight fit. This was very hard to get off in episode 1, and even harder to get on here. The radiator end caps are plastic, so I was fairly certain that I would break them off while pressing as hard as I could to get the hose on. It took me around 20 minutes to make it happen by standing on the driver's side and then pressing it with both hands as hard as I could. I put the clamp on the water pump outlet, threw on the expansion tank hose to the thermostat housing, and pulled out the blue cloths that I had protecting the turbo outlet. I bought some Mishimoto charge pipes, but while assembling I realized that they accidentally sent me 2 driver's side pipes and no passenger side pipe. So I angrily moved on to the Mishimoto turbo inlet tubes that I also got. I used the original tubes to match up the Mishimoto silicone boots, and also to transfer over the AFE intake's PCV extender tube thing. The Mishimoto tube is literally 0.5 millimeter less in interior diameter, so the tube wouldn't fit, even with me trying to use a mallet. So I finished installing the boots and installed the securing pins. On the truck, I pulled out the rest of the cloths that were protecting the turbos and installed the inlet tubes. The charge air pipes were next, and they were surprisingly difficult to install because the hoses needed to be held in place to seat all the way down and then be tightened. This was much easier with 2 people, since one person needs to be on top, pressing from above, and then the other person would be in the wheel well to actually tighten down the hose clamps. Next, I installed the cold side charged air pipe into the throttle body. I started reconnecting the PCV hoses to the turbo inlet, and I also clipped the intake map sensor wire into the inlet tube and connected the cold side charged air pipe sensor. I got a little confused with the driver's side turbo inlet as it changed the orientation of the connections. I removed one of the hoses, rotated the connection fitting on the inlet, and I needed to modify, or really I feel like destroy, the stock hose that connects the cold charge air pipe to the driver's side turbo inlet. The new Mishimoto pipe has connectors at a different angle and needs a longer hose, so I stole the connectors from that old hose and installed them into the supplied hose that came with the inlet tubes. Then I installed my blow-off valve vacuum hose, reinstalled the airbox, and I used the supplied rubber cap to finally cap off the recirculation valve hole in the turbo inlets, which is pointless with a blow-off valve. Then I could reconnect the various PCV hoses that I had removed. I installed the lower coolant reservoir hose, bolted it down to the radiator using a 10mm socket, and then connected the passenger side hose to the radiator and the driver side hose to that thermostat housing hose. I bought a new coolant cap as preventative maintenance, and surprisingly it's a whole new design. The last thing to install was the intake before filling her up with oil and coolant. I used the Mishimoto pressure tester and found that I was leaking somewhere, some air, so I double-checked all the bolts and found that one water pump bolt that I had randomly missed. I also went back over the new radiator hoses as the pre-installed clamps were a little loose. Then I could vacuum fill the coolant, which ended up taking a little over 2.5 gallons initially, and I topped it off with another quart or so. I reinstalled the battery off camera, and it was time to actually start her up. This sounded rough. The phasers seemed to rattle at start, and the engine was ticking, for a little while anyway. I also threw several codes for engine misfires. Google told me to reset the PCM adaptation, so I used the 4scan service procedure to reset the PCM and clear the codes. After that, the truck ran perfectly. So, lots of final thoughts. This video was not as detailed as previous ones because I was seriously running out of time to get the project done since it took me 6 days. You'll see that I did not include torque values for the hose clamps on the coolant hoses or the turbo tubes, and that's just because I had some aftermarket parts, and when I actually did follow the recommended torque, it was so low that I couldn't even feel a click on the torque wrench. I reused most of the bolts, including the fuel tube bolts, despite the manual saying to replace those specifically. I did replace the high-pressure fuel pump bolts since that's under a lot of pressure with the engine running. The other 8mm bolts used on the coolant parts, I think that those should be replaced also since they have a torque and then a specified degree. That makes me think that they're supposed to stretch and that reusing is a bad idea. I didn't replace them though since I honestly didn't think about it, but Ford part numbers for bolts are not friendly anyway, and most schematics don't label the bolts. However, they did for the water pump and other cooling components. I edited out how long it took me to do all the coolant hoses. This is because I didn't have the special unlock tool for those hose clamps, and I just couldn't get them to unclamp easily. I constantly reference the Ford service manual while getting this done for torquing procedures, and also just to verify where everything goes, since the drawings were good references. You don't see the PDFs being highlighted in this video because Ford holds a copyright on those images. If you plan on knocking this out yourself, I recommend buying a 72-hour pass on the Ford Workshop website and downloading the PDFs for yourself. Like I said in the first video, there is no direct instruction set for this, but I used the engine assembly and disassembly, as well as the engine removal and install with the body on during this whole procedure. There were several other parts that I had to access also to identify torquing procedures because the instructions just skip some steps. If you're wondering why I was buying so many Mishimoto parts, it's because they had aluminum connectors on the radiator hoses and inlet tubes, so I thought that they'd be, the best item to buy. The coolant pressure tester and vacuum filler I bought a while back when doing a flush, but the charge pipes and soon the catch cans are part of a new small relationship that I have with Mishimoto. I'm still paying for stuff, but I would have gone with them anyway. Last note is that I made a lot of what I would call serious mistakes. The biggest one was stripping out a few threads on the crankshaft interior. This was just dumb. The install tool is only really there to get the balancer on far enough for the bolt to fit, so there was no reason for me to try and seat it all the way down. I was extremely lucky that it wasn't bad and I had the right size tap. I also cracked the alternator wire insulator while using a mallet, but that wasn't really terrible, and it still worked. I obviously completely missed the one water pump bolt. I think it was because I was picturing it as part of the outlet, like a bolt that I had just stuck in there as part of the outlet, instead of the actual pump installation. The last minor mistake was getting the wrong size belt for the new alternator. That's because it's an aftermarket alternator. That caused me an extra week of heartache, but that's a whole other video. If you're wondering if I thought that it was worth doing it myself, the answer is still yes. Ford Tech Mickey Loco's video where he outlined the $6,000 cam phaser repair parts that's what I use to actually purchase my parts. The parts at online prices were around $1,600 shipped, so that would be nearly $4,500 in labor for the job. The project took me a week, and I definitely don't make anywhere near $4,500 a week, so just from a financial standpoint, it makes sense. I did recently see some posts on the forum about how Ford may still help cover the phasers. So if I could go back, I would obviously, number one, get an extended warranty and put it back to stock in the event of failure. Or number two, try and get Ford to pay for a portion of it and then pay out of pocket for the rest of the preventative maintenance parts. Your time is valuable, and this was 6 days that I could have spent with my wife and the pups. Anywho, that's all I got. I'm so glad that the phaser video series is done because it was awful to edit. But thank you for watching, and I will see you next time.